Hi, my name's Michelle. You may know me from Lab Muffin Beauty Science, where I talk about the science behind beauty products. I got the university medal in chemistry, I have a PhD in chemistry, and I've been teaching chemistry for about 15 years. I'm also a chemistry teacher as my day job. A few people have asked me to do some chemistry tutorials, so I'm tackling one of the most common topics in chemistry, titration. The most straightforward type of titration is where you have two solutions, usually an acid and a base. You put a known volume of one solution in a conical flask. You add the other solution into the flask until they've just reacted. You know the concentration of one solution, and you need to work out the concentration of the other solution. This calculation is actually a straightforward mole calculation. First, I'm going to go through the most common mistakes I see students make with titration calculations. It's really tempting to use the formula C1V1 equals C2V2 for titration calculations because it means you don't have to think very much and you just have to sub numbers into one formula. This is a trap because it only works for reactions where there's a 1-to-1 mole ratio, so you'll have to learn the proper method for other ratios anyway. You can also make it work for other mole ratios by adding numbers in front of C1V1 or C2V2, but it's super confusing which number you add where, and from the many students I've taught over the years, even the best students who try to do this method get confused. So you're going to spend tons of effort trying to work out how to put in the ratio. You may as well just learn it the proper way, which I guarantee you is harder to stuff up. The other really common mistake I see is that students get confused about what number to sub in where. The easiest way I think, if you're just starting to do titration calculations, is to label the numbers they give you in the question with the solutions they correspond to. This works for any other equations too. I also recommend labeling your pronumerals, N, C, and V, with the substances they correspond to. You'll see me doing this a lot in my calculations. It makes it much easier to work out which numbers to use in all mole calculations. Okay, let's look at a straightforward question. First, let's read the question and label the numbers. Endpoint means the end of the titration, where you have just enough of each substance to have the ratio of reactants that match the mole ratio in the balanced chemical equation. Now, step 1 in any mole calculation is to write a balanced chemical equation. For acid-base reactions, the acid and base react to form a salt or ionic compound, and water as well if you have a hydroxide base. So for this reaction, the products are sodium chloride and water. The equation is already balanced, so we're done. For acid-base reactions, you can also balance them by matching the number of protons and proton acceptors. Here we have one proton in HCl, the H+ ion, and one proton acceptor in NaOH, the hydroxide ion. The second step is to convert what you can to moles. In titration calculations, you're dealing with concentrations and volumes, so the equation you need is C equals N on V. If we rearrange this, we get N equals CV. Remember that the units for C is moles per litre, and for V it's litres. In titration calculations, you often get volumes in mils, so keep in mind that you'll probably need to divide by 1,000. Looking back at the values we have, we know the C and V for NaOH, so we have one unknown and we can calculate the moles of NaOH. The next step in a mole calculation is to use the mole ratio to work out the moles of unknown, that is, what you're trying to calculate. The mole ratio comes from the numbers in front of the substances in the balanced chemical equation. In this reaction there are no numbers, which means 1-to-1, so the moles of HCl is equal to the moles of sodium hydroxide. Now we have the moles, we also have the volume, so now we have one unknown and we can find the concentration. Divide the moles by the volume. Don't forget significant figures. We round the answer to the least number of significant figures that we used in this calculation, which was 3. Don't forget the units in the final answer as well. And that's the end. A couple of extra tips. Note that we don't actually need the full balanced equation to solve this question, since we only use the mole ratio to convert between the reactants. So if you know the ratio of reactants, you can still solve the titration calculation. Sometimes the question will also give you a number of titration volumes, since in real life, the titration will be repeated a bunch of times to improve reliability. You need to remove any outliers, then use the average volume in your calculation. In this sort of question, there's usually one outlier.